The five principal layers of Earth's atmosphere consist of the troposphere, stratosphere, mesosphere, thermosphere, and then the exosphere. The troposphere is the lowest part of the atmosphere, which stretches out from ground level to about 10 kilometers in the sky. Over 75% of the air in Earth's atmosphere remains in the troposphere. At the very top of the troposphere lies the tropopause. In the troposphere and up to the tropopause, the temperature decreases by 6.5 degrees Celsius per every higher kilometer you are. Extending to about 50 kilometers above the ground is the stratosphere, the second layer of the atmosphere on Earth. The ozone layer can also be found in the stratosphere. The ozone layer acts like a shield to protect our planet from the harmful ultraviolet beams from the sun, which protect us from health damages such as skin cancer. While the top of the tropopause is about negative 51 degrees Celsius, the higher you go, the warmer the temperature actually gets. Temperatures can get up to negative 15 degrees Celsius because the ozone absorbs ultraviolet radiation from the sun, which significantly heats up the stratosphere. From 50 kilometers above the ground starts the mesosphere, and it ends at the mesopause, about 85 kilometers above Earth's surface. Being different than the ozone-filled stratosphere, the temperature decreases the higher up you go. If the stratosphere could get up to negative 15 degrees Celsius and the region up to the mesopause reaches a stunning negative 90 degrees, that means that the temperature decreases at 2.14 degrees Celsius for every kilometer you go up. The thermosphere is the fourth layer of Earth's atmosphere. The thermosphere lies above the mesopause and is a region in which temperatures again increase with height. This temperature increase is caused by the absorption of energetic ultraviolet and X-ray radiation from the sun. The region of the atmosphere, which lies above 80 kilometers of Earth's surface, is called the ionosphere. Since the energetic solar radiation knocks electrons off molecules and atoms, they turn them into ions with a positive charge. The total distance from beginning of the thermosphere to the thermopause is about 400 kilometers above Earth's ground. Finally, more than 400 kilometers above Earth lies the exosphere. The exosphere contains a lot of oxygen and hydrogen atoms, which rarely collide into each other. Sometimes the atoms escape out of Earth's atmosphere and into outer space. Now, let's shift gears and talk about Mars's atmosphere. Unlike Earth's 5 atmosphere layers, Mars only has 3. Mars has a troposphere, mesosphere, and exosphere. Mars's troposphere is twice as large as Earth's troposphere, so it extends up to 20 kilometers from Mars's surface. The air temperature there is warm. Extending another 80 kilometers is the mesosphere, which has very harsh and cold temperatures. The final layer is the exosphere, with air temperatures being extremely hot. Mars's thin atmosphere and its greater distance from the sun mean that Mars is much colder than Earth. The average temperature is about negative 60 degrees Celsius, although it could vary from negative 125 degrees Celsius near the poles during the winter to as much as a comfortable 20 degrees Celsius at midday near the equator. The atmosphere of Mars is roughly about 100 times thinner than Earth's, but it is still thick enough to support weather, clouds, and winds. One thing that Mars and Earth also share is located at the top of their exospheres, called the magnetosphere. The magnetosphere is the most outer region of the atmosphere, where charged particles spiral along the magnetic fields. The Earth behaves like a huge magnet. It traps electrons and protons, concentrating them in two bands about 3,000 and in between 3,000 and 16,000 kilometers above the globe. These are known as the Van Allen radiation belts. Because Mars lost its magnetosphere, Mars is vulnerable to the sun's ultraviolet radiation. However, since the particles borne by the solar wind through the solar system are typically electrically charged, the magnetosphere acts like a protective shield against the solar wind. In addition to particles, the solar wind carries magnetic field lines from the sun. As magnetic field lines cannot pass through electrically conductive items such as Mars, they drape themselves around the planet, creating a magnetosphere. Even the planet does not necessarily have a global magnetic field. We have storms of all different sizes. Hurricanes also happen on Earth, but they never cross the equator due to the Coriolis effect. The Coriolis effect pulls hurricanes away from the equator by force, making it physically impossible for any hurricane to cross from one hemisphere to another. Weather on Mars is more extreme. It is further from the sun than Earth. Like Earth, Mars has widespread dust storms. The atmosphere is way thinner, and they still have winds so fine that particle dust is blown by the wind. These could last weeks and could send dust over 60 miles an hour. These storms are also depleting the remaining water on Mars. Compared to Earth, dust storms here are actually way worse. Some of our dust storms could even be seen from space. The wind on Mars is weaker than Earth's, and this is caused by the weakened atmosphere. The fastest winds on Mars are around 106 kilometers per hour, while Earth has experienced winds up to 490 kilometers per hour. Scientists believe Mars actually had stronger winds and more powerful storms at one point, but due to the fact that the core is cooled and the atmosphere is so thin now, it isn't possible anymore.
Earth and Mars from a basic viewpoint are completely different. However, their climates are more similar than most would think. 70% of Earth's surface is covered in water, while Mars has no liquid water on the surface. Mars has surface ice and underground water. Temperatures on Mars vary from 20 degrees Celsius to negative 153 degrees Celsius, while temperature on Earth ranges from negative 89 degrees Celsius to 58 degrees Celsius. These temperatures are very different, but at one point scientists think Mars was extremely similar to Earth. They think its core just cooled at a faster rate. Once the core cools, there isn't a magnetic shield to protect from solar radiation, and everything in the climate as a result dies. The landscape has large sand dunes, craters, rock formations, mountains, and volcanoes. Everything is red and brown. A solar day on Mars lasts 24 hours and 40 minutes. This doesn't affect the climate because there isn't any life.